Okay, hello once again, everybody. This is I think this is the yes, fourth part four of chapter two, energy head, and the application of the energy equation. Now let's go to the illustrative problems. So we'll try to apply now all the principles and concepts we have discussed in the previous discussions or lecture or videos. I hope you have watched those videos. You did not jump into this part just to see how things are applied. I think we should be well acquainted with the underlying principles and underlying concepts, no, before you proceed to this part of the lecture. So this is part 4. Let's start with solving some problems already. So problem 1, I did not write the entire problem, but I have written medyo mahaba that might consume the entire the space of the whiteboard. So I have just written here the given items. I'll just be reading the problem na lang, no. And anyway, you have your modules with you, so I suggest you should be watching this video with your modules with you, no, para mas maganda. Okay, mas maintindihan natin. Okay, problem 1. A fluid is flowing in a horizontal pipe 8 inches in diameter with a mean velocity of 10 feet per second. The pressure at the center of the pipe is 5 psi. Psi is pounds per square inch. Now, that's a unit for pressure. I hope you can still remember our discussions before about pressure, different units for pressure. Okay, and the elevation of the pipe above the assumed datum is 15 feet. Compute the total head in feet if the fluid is letter A, water, if the fluid is letter B, oil with a specific gravity of 0.8, and letter C, molasses with a specific gravity of 1.5. So we are to compute the total head. When we say total head, that means the total energy. No, remember from our previous discussions that we have converted yung energy into an equivalent energy head or head only, you know, to simplify the analysis or the application of the Bernoulli's energy theorem or energy equation. Okay, so we are to solve the total head or total energy in that particular point in the pipe. Okay, so the total energy is just put the sum of the kinetic energy and the pressure energy and the elevation energy. Okay, so let's solve letter A. If the liquid is water, what would be the total energy? So what would and let's try to compare later on the differences, no. Ano kaya ang mapoproduce ng energy kapag water, oil, or molasses yung liquid, and we will try to compare the results later on. So the total energy is equal to the sum of all potential and kinetic energy. We have V squared all over 2G plus P over gamma plus Z. So velocity head, pressure head, and the elevation head. So first, let's try to solve each item in the equation. Okay, the right side of the equation. Now, what is the velocity head? Given naman yung velocity. Okay. The pressure head, given yung pressure at 5 psi. But take note, it is in psi. The rest of the terms are in naka-feet siya. So, naka-inches ito. So, I think it would be better if we convert this pressure into an equivalent pressure in feet also. So, pounds per square feet na lang ito, square foot. So, i-convert muna natin yung pressure. So, this is PSI. So, that's pounds per square inch, convert natin sa PSF, it's pounds per square foot, to be uniform with the rest of the term, the units in the term, since sa equation natin. Okay, so how many inches in 1 foot? So we have 12 inches in 1 foot. Since it's a squared quantity, square natin ito, so cancel yan. Okay, so we're left with what would be the equivalent pressure in PSF at 720 pounds per square foot, or that is in PSF. I think we're ready. So the total energy if the liquid is water is equal to V squared all over 2G, that's 10 feet per second. What is G in the English system? That's 32.2 feet per second square, plus P over gamma. So P should be in PSF. That's 720. 720 pounds per square foot divided by gamma of water in the English system. I hope you can still remember that is 62.4 pounds per cubic foot, plus the elevation head, which is 15 feet. So the total energy at that particular point in the pipe, and when the liquid is water, it's equivalent to 28.091 feet. So that is the energy head, total energy if the liquid is water. Now the same would be true if we try to solve the different, using different liquids. Let's say letter B. If the liquid is oil at a specific gravity equivalent to 0.8, so the equations would be the same. What would be different is, well, the difference would be the unit weight, no? So the energy is equivalent to, we have, so 10 feet per second square, square divided by 2 times gravity, plus we have 720 pounds per square foot divided by what would be the equivalent unit weight of oil, no? You still remember how do you convert, given yung specific gravity ng oil, how do you convert it to an equivalent unit weight? So we simply multiply yung specific gravity ng oil sa unit weight ng water. So we have 0.8 times 62.4 pounds per cubic foot, plus the elevation head na 15 feet. So the energy if the liquid is oil is equivalent to 30.976 feet. So that is the energy if the liquid is oil. Now what if the liquid is molasses? So letter C, if the liquid is molasses, how do you pronounce it? Molasses or molasses? I don't know. So the specific gravity of molasses is 1.5. Okay, so for the total energy, I will no longer put the units. I'm afraid the space would be not enough. So I will no longer put the units, but what the difference would be the unit weight dun sa my term, sa my pressure head. Okay, so we have 10 squared all over 2 times 32.2 plus 720 divided by, we multiply the specific gravity of molasses by the unit weight of water in the English system. So 0. It should be 1.5. 1.5 times 62.4 plus 15 feet. So the energy, the total energy, if the liquid is water, is water to molasses, let's say it's 24.245 feet. So that would be the energy if the liquid is molasses. Now, you compare the three energies. Ang difference lang yan is the unit weight, no? The unit weight, their unit weights. So, observe natin, pag mas mabigat yung liquid, mas konti yung energy na naproproduce. Ito, for example, yung molasses is heavier than water. So, the water's specific gravity is 1, no? So, molasses, so any material that has a specific gravity greater than 1 is heavier than water. So 28 compared to 24, so mas malaki yung na-produce na energy pag water since it is lighter than molasses. And of course, among the three, mas malaki yung energy na na-produce using oil because it's lighter, no? It's the lightest among the three liquids in this particular problem. Okay, so that's how you solve for the total energy at a certain point in a certain system. Okay, so simply the sum of the kinetic and potential energies. Okay, so that's it. We will have another video for the next problem. I think the next problem would require a pretty long solution. Yeah. So, separate video na lang yung sa second problem. Okay? So, see you sa second example.